right, day 18. Make sure you have watched the first part of the video, 18-1, before we do this lesson, because it's important that you have watched that video. All right, it says one of the main goals in studying geometry is to develop your ability to reason critically, to draw valid conclusions based upon observations and proven facts. Master detectives do this sort of thing all the time. Take a look at Sherlock Holmes' use of seemingly insignificant observations to draw amazing conclusions. Could you follow Sherlock Holmes' reasoning as he deducted his thought process? All right, so if you watch the video, it was, he was trying to figure out who attacked, and he was able to give a very vivid description of who attacked. Were you able to follow that? All right, so that's kind of what we're going to be looking at today. We're going to be looking at unknown angle proofs and writing proofs. Proofs is one of the big things with geometry. All right, so let's look at this. I want to remind you that you are drawing on the same set of facts that we've been using in the last few days. All right? 3 dots indicate that the proof has been completed. All right, so we're going to be looking at this. In geometry, we follow a similar deductive thought process, much like Holmes's uses, to prove geometric claims. Let's revisit an old friend, solving for unknown angles. Remember this one? You needed to figure out the measure of A and use the fact that an exterior angle of a triangle equals the sum of the measure of the opposite interior angles. The measure of angle A must therefore be 36 degrees. All we did was do 78 minus 42 to give us the measure of angle A. Suppose that we rearrange the diagram just a little bit. Instead of using numbers, we will use variables to represent angle measures. Suppose further that we already know that the angle of a triangle sum to 180 degrees. Given the labeled diagram at the right, can we prove that x plus y is equal to z, or in other words, that the exterior angle of a triangle equals the sum of the measure of the opposite interior angles? All right, so in other words, they want to know, can we prove that x plus y is equal to z? Even though we have been talking that the exterior angle is the measure of the 2 remote interior angles, how do we know that? All right, so let's look at this proof. It says label angle W as shown in the diagram. So it gave angle W as the third angle of the triangle. The measure of angle X plus the measure of angle Y plus the measure of angle W is 180 degrees. How do we know that? Because the sum of the angle measures in a triangle is 180 degrees. We already know that. The measure of angle W plus the measure of angle Z is equal to 180 degrees because they form linear pairs. A linear pair gives you supplementary measurements. That's 180 degrees. The measure of angle X plus the measure of angle Y plus the measure of angle W is equal to the measure of angle W plus the measure of angle Z. Guys, we use the substitution property for this. In other words, I'm just saying I know that all of this equals 180, but I also know that W and Z together equal 180. So the measure of angle X plus the measure of angle Y has to equal the measure of angle Z. And you see these 3 dots here, they're very small, but that shows the proof is finished. We are finished. Notice that each step in the proof was justified by a previously known or demonstrated fact. We end up with a newly proven fact that an exterior angle of any triangle is the sum of the measure of the opposite interior angles of the triangle. This ability to identify the steps used to reach a conclusion based on known facts is called deductive reasoning. It is the same type of reasoning that Sherlock Holmes used to accurately describe the doctor's attacker in the video clip. Alright? Deductive reasoning, guys, that is a vocabulary word that you need to make sure you know. Alright, so let's look at this. Let's do number 1. You know that angles in a line sum up to 180 degrees. Prove that vertical angles are equal in measure. Remember, vertical angles, x and z, w and y. So we want to prove that those vertical angles are equal in measure. So we need to make a plan. How am I going to go about doing this? What do you know about the measure of angle W and the measure of angle X? What do you know about the measure of angle Y and the measure of angle X? Well, what do you know, guys? They are linear pairs. And because they are linear pairs, W and X is a linear pair, X and Y is a linear pair. They sum to 180 degrees. Alright? And if you want to write a little note, they are linear pairs. Okay? They are linear pairs. What conclusion can you draw based on both pieces of knowledge? Well, if I know that WX is a linear pair and that YX is a linear pair, then what do I know about W and Y? Well, X never changes in either one of those equations. It doesn't get bigger or smaller, so W has to be equal to angle Y. Has to be. So now it says write out your proof. Alright guys, this is an introduction to proofs. Proof is simply step by step how you figure it out. Alright, so what did we know? What do we know? We know that the measure of angle W plus the measure of angle X is equal to 180 degrees. Alright? How do I know that? Why do I know that? All we're doing is starting up here. Because linear pairs form supplementary angles. Okay? What other piece of information did we learn up here? We learned that the measure of angle Y plus the measure of angle X was 180 degrees. Why? Because linear pairs form supplementary angles. I have to know both pieces of information because if I don't, I'm stuck. Just knowing that I have one pair of linear angles or one linear pair does not help me. Alright, so now that I know that, now I know that the measure of angle W plus the measure of angle X is equal to the measure of angle Y plus the measure of angle X. How do I know that? Because I'm simply doing substitution, property of equality. I'm substituting. They're both equal to 180 degrees, so I can substitute this in for this, or this in for 180 here. And that is the substitution property of equality. Okay? So now that I know that I can substitute all of that in, I know that the measure of angle x never changes, so I can now prove that the measure of angle W is equal to the measure of angle Y. And I'm going to put those 3 dots because it shows me that my proof is concluding. Alright? Because I can subtract the measure of angle x from both sides. So subtraction, property of equality. Okay? If I subtract the measure of angle x, it doesn't matter because it's the same thing. Even though I don't have a number in there, I know the measure of angle x is the same on both sides of my equation. I can subtract that, and I end up with the measure of angle W is equal to the measure of angle Y. And you have just completed your first geometric proof. All right, number 2. Given the diagram to the right, prove that the measure of angle W plus the measure of angle X plus the measure of angle Z is equal to 180 degrees. Make a plan first. What do you know about the angle X, angle Y, and angle Z? Okay, so the first thing I know, it gives me a hint. What do you know about angle X, angle Y, and angle Z? Well, there are 3 angles in a triangle, so what do we know? We know that that equals 180 degrees. Okay? And this is kind of like the example that they introduced us in our discussion. Finding the measure of angle, or when we did X, Y, Z, and then W. Alright, so what do I know about the measure of angle Y plus the measure of angle X plus the measure of angle Z? It's going to give me 180 degrees. So the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180 degrees. And guys, you'll notice with a proof, I give a statement. I always have to tell why. How do I know? The sum of the angles of a triangle is 180 degrees. All right, that's how I know. It's given, it is a fact that I know that the sum of the angles of a triangle are 180 degrees. All right, so now that I know that that's equal to 180 degrees, why is that important? All right, well, what do I know about the measure of angle W and the measure of angle Y? They have to be equal. Why? Because they are vertical angles. So the measure of angle Y has to be equal to the measure of angle W. Vertical angles are equal in measure. Okay, so now I know that angle W is congruent to angle Y. I'm going to mark that on my figure here. All right, so now, does that help me? Well, if W is equal to Y, then it wants us to prove that the measure of angle W plus the measure of angle X and the measure of angle Z is equal to 180 degrees. Well, if I know that X, Y, and Z are 180 degrees, and I know that W and Y are equal, now can I prove that? I can by substitution. I'm substituting, now that I've proven that Y is equal to W, I I can plug in the measure of angle W for the measure of angle Y. So the measure of angle W plus the measure of angle X plus the measure of angle Z is equal to 180 degrees. And that is simply, I'm substituting that in. Okay? All right, given the diagram to the right, prove that the measure of angle W excuse me, is equal to the measure of angle Y plus the measure of angle Z. So it wants me to prove that W is equal to Y plus Z. All right, so let's think about this for a second. Well, what do I know about W? W is actually equal to the measure of angle X and the measure of angle Z. So the measure of angle W, oh, I forgot my 3 dots here, guys, sorry. That's something new I'm not used to. So those 3 dots tell me that I'm finished. All right, so the measure of angle W is equal to the measure of angle Z plus the measure of angle X. How do I know that? Because exterior angle of a triangle equals the sum of 2 interior opposite angles. Okay? All right. So I now know that W is equal to the measure of those two. All right. So now that I know that, what else do I know? Well, what do I know about X and Y? I've somehow got to get that Y in there. Right now I've got W, X, and Z. So what do I know about X and Y? I know they are vertical angles, and because they're vertical angles, they are equal in measure. So the measure of angle X is equal to the measure of angle Y, because vertical angles are equal in measure. Okay? Vertical angles are equal in measure. All right, so now that I know I have vertical angles, think about this. Can I substitute anything? If I know that X is equal to Y, well, what happens if I replace this X with this Y? Do I get what I'm trying to prove? The measure of angle W is equal to the measure of angle Y plus the measure of angle Z? I do. So my conclusion would be the measure of angle W is equal to the measure of angle Y plus the measure of angle Z. Substitution property. Of equality. Okay? All right, number 3. In the diagram to the right, prove that the measure of angle Y plus the measure of angle X is equal to the measure of angle W plus the measure of angle X. You will need to write in a label in the diagram that is not labeled yet for this proof. So it says I need to add something for this proof. All right, so let's figure this out. I notice nothing is marked as far as congruence or parallel or anything like that. All right, so I want prove that measure of angle y plus the measure of angle z is equal to the measure of angle w plus the measure of angle x. So I want to prove basically that all of this is equal to all of this. Alright, so here I've got A. Let's look at A for a second. What do I know about the measure of angle A and the measure of angle X and the measure of angle W? The measure of angle A plus the measure of angle X plus the measure of angle W. Well, I know that that equals 180 degrees. That's a big triangle. That's the big triangle. So the measure of angle A plus the measure of angle X plus the measure of angle W is equal to 180 degrees. The sum of the angles of a triangle is 180 degrees. All right, now, what else do I know? What about the small triangle? Measure of angle A plus the measure of angle Y plus the measure of angle Z. Is equal to 180 degrees. Because that's the small triangle. Alright, because the sum of the angles of a triangle is 180 degrees. Alright, so I've now proven that we have that. Now, let's look at this. I know all of this equals 180. I know all of this equals 180. So because I know it's all equal to 180, look what I can write. The measure of angle A plus the measure of angle X plus the measure of angle W is equal to the measure of angle A plus the measure of angle Y plus the measure of angle Z. How do I know that? Because all I did was substitute. So substitution property of equality. I just substituted this part in for 180 degrees. Okay? Notice I'm working off of each step. The step that I'm writing works off the step before. The step I'm writing works off the step before. This step works off the step before. Okay? Alright, so now I've got substitution property of equality. Okay? Now, I've substituted. If I have the measure of angle A on both sides, so if I subtract that, look what I end up with. The measure of angle Y plus the measure of angle Z is equal to the measure of angle W plus the measure of angle X. That's what I'm trying to prove. So I can now prove that. By subtraction. I simply subtracted the measure of angle A. Even though I did not know what the actual measure was, guys, if I take measure of angle A and I subtract it from the measure of angle A, I know that they're going to cancel out. It's going to zero out. Okay? So subtraction property of equality. Number 4, in the figure to the right. Now this tells me some information. It tells me that AB, segment AB is parallel to segment CD, and it tells me segment BC is parallel to segment DE. I want to prove that the measure of ABC, so this angle here, is equal to the measure of angle CDE. So I want to prove that these two angles are congruent. How do I do that? Well, more than likely, since they told us we have parallel lines, we're probably going to use what we know about transversals. So let's look at that. On the measure, let's see, ABC and DCB. All right, let's work with what we know about these two parallel lines. We'll consider this a transversal of these two parallel lines. All right, so I'm going to kind of extend it here. All right, so what do I know? Because I need to figure out something here that's going to help me when I start dealing with these two lines. So looking at this, what do I know? I'm dealing with measure of angle, this angle here. All right, I know that. So what do I know about the rest of this? Well, I know that the measure of angle ABC is equal to the measure of angle DCB. This angle. How do I know that? Because when two parallel lines are cut by a transversal, alternate interior angles are equal in measure. And we're just going to write alternate interior angles. All right? Alternate interior angles are equal. And that's what these are. They are alternate interior angles on the inside of the parallel lines and opposite sides of the transversal. All right? So now that I know those two angles are congruent, now let's look at this. Let's go to these two lines that are parallel. Here's my transversal. Guys, what do you see? I now know that the measure of angle DCB is congruent to the measure of angle CDE. How do I know that? Once again, they're alternate interior angles. They're on a different set of parallel lines, but they are alternate interior angles. So now that I know that this angle and this angle are equal, and that this angle and this angle are equal, look at what I can do. Looking at these two, guys, they have this in common. So because they have that in common, I can substitute something in for it. So I can substitute the measure of angle ABC is equal to, substitute this in for this, the measure of angle CDE, and that is simply by substitution. All right, I'm simply substituting what I know in. All right. All right, number 5, the figure to the right. Prove that the sum of the angles marked by arrows is 900 degrees. You will need to write in several labels into the diagram for this proof. All right, so we probably need to go ahead and write in some, let's label our angles here, or label our degrees. So we'll label this A degree, B degree, C degree, D degree. All right, and then we'll go to up at the top. So we'll do E, F, G, and H. And then we'll go over to the side. And we've got I, J, K. And we don't use L because that usually means line. So we're not going to use the L. We'll just go M. All right, so what do I know? Look at this, guys. This arrow tells me something. That means all these angles come at a point. Going back to when we were talking about construction, What do we know about angles that come to a point? They equal 360 degrees. So, I know that A plus B plus C plus D is equal to 360 degrees. Alright? Angles at a point sum to 360 degrees. Now, because I know that, then I know that about this part up here, up at the top. So E plus F plus G plus H is 360 degrees. Same reason. Angles at a point sum to 360 degrees. Because I know that about these points and these points, then I know that about this point. Because that arrow tells me. So I plus J plus K plus M is 360 degrees. Angles at a point sum to 360 degrees. Okay? Now, since I know that all of that equals 360 degrees, I can substitute. And then I can figure out what all of that equals to. Alright, so what do I know about A plus B plus C plus D plus E plus F plus G plus H plus I plus J plus K plus M? I know that it equals 1080. Alright? And that's simply substitution property. Okay? Alright, so now that I know that, alright. So, notice what I have here though. I have a triangle. What do I know about that triangle? What do I know about DH and I? Well, DH and I equal what? They equal 180 degrees. Because the angles of a triangle sum to 180 degrees. Okay? So now it wants us to prove that the angles marked by the arrows. So let's look at that. So A, B, C, E, F, G, and K, J equal 900 degrees. Well, if I know what all of it equals, and then I know what the middle equals, I can subtract that, and I can prove that A plus B plus C plus E plus F plus G plus J plus K plus M is equal to 900 by subtraction. I could subtract the whole, which was 1080, and the 180 in the middle, and that would give me 900. Okay? So I've proven that they are 900 degrees. All right, last one. In the figure to the right, prove that the sum of the angles marked by, I'm reading the wrong one. In the figure to the right, prove that segment DC is perpendicular to segment EF. What does perpendicular mean? It means that it's going to form a right angle. So it wants me to prove that DC is perpendicular to EF. It wants me to prove that there's a right angle somewhere here. All right? Draw in label Z. All right, so draw in label Z. All right, so let's think about what we know. Well, it's given us A and E. I'm missing something here. But I know that this and this and this all equal 180 degrees. All right, so I'm going to put the measure of angle A plus the measure of angle E plus the measure of angle EFA equals 180 degrees. How do I know that? The sum of the measures in a triangle is 180 degrees. I'm going to come down here, actually, so I have a little bit more room. It makes more sense. Okay? So I know that the sum of the angles of a triangle are 180 degrees. All right, so now, what do I know? Well, can I figure out what EFA is? Yes, I can. Because if this is 60 and this is 60, then that's 120. 180 minus 120 is 60. So the measure of angle EFA is 60 degrees. And I can substitute, say that's a subtraction property, because I did that, I subtracted. All right, I subtracted 120 from 180. All right. So now let's go to the other triangle for a moment, now that I figured this out. All right, and you can actually write that in there if you'd like. That's fine. So now let's go to the other triangle. So I know that we're going to kind of do the same thing with this. So the measure of angle B plus the measure of angle C plus the measure of angle CDB is 180 degrees, because the sum of the angles of a triangle is 180 degrees. All right, now can I figure out the measure of angle CDB? I can. The measure of angle CDB is equal to, well, that's 90 plus 60 is 150. 180 minus 150 is equal to 30. And once again, that's just a subtraction property. Okay, so now I know that this is 30 degrees. All right. Now, so let's go back to my goal. My goal is to try to figure out that there's a right angle somewhere in this part right here, okay? So I'm going to label this, and it told us I needed to label that. I'm going to label this Z, because I need to put that point there. I need a point to help me. Now, notice I have a small triangle here. Okay? I have a small triangle here. So, here's what I know. I know the measure of angle CDB plus the measure of angle EFA plus the measure of angle DZF, okay, going to give me 180 degrees. Why do I know that? Because the sum of the angles of a triangle equal 180 degrees. Okay? So now I can look at this. The measure of angle DZF is 90 degrees. Well, because 60 plus 30 is 90, 180 minus 90 is 90. Okay? And since it's 90 degrees, what do I know about my lines? They have to be perpendicular. So DC has to be perpendicular to EF, because the definition of perpendicular lines mean they form 90-degree angles. I was hoping that we were back in school before I had to introduce proofs to you. Guys, do not flip out over proofs. They are something that we're going to be using throughout this year, but it literally is just step by step how you work it out. Only you have to write it in the words. So don't get extremely upset and confused about proofs. Give them a chance.